Hello again and welcome to Safety Short Series. Today we'll be posting 27th video of the series and today's topic is hazard control of electrical safety. Now today's topic become interesting for we are going to talk about energy source. Yes, you work with power tools, electrical circuit, there is a risk of electrical hazard, especially electrical shock. Anyone can be exposed to the hazards at home or at work. Workers are exposed to more hazards because job sites can be cluttered and with tools and materials, fast-paced and open to weather. The risk is also higher to work because many jobs involve electrical power tools. Now, electrical workers must pay special attention to electrical hazards because they work on electrical circuits, and contact can cause electrical current to flow through the body, resulting in shock and burns. Serious injuries or even death may occur. As a source of energy, electricity is used without much thought about the hazard it can cause. Because electricity is a familiar part of our lives, it often is not treated with enough caution. As a result, an average one worker is electrocuted or suffers electrical related injury on the job every day of every year. So, what to do? The very first step is recognition. First, we must be able to identify or recognize that yes, the threat exists. Acceptance is very important. Without it, we cannot move forward. Electricity has long been recognized as a serious workplace hazard, exposing employees to electrical shock, electrocution, burn, fire, and explosion. Every year, as we see news, social media, we hear about incidents in the root cause is energy source that links to electricity. We hear about electrocution, person's death, and often word that pops out is shock or short circuit or outrage. Remember, energy source is ignition source, power source is heat source. It's also itself inherent property of causing harm, hence should be considered as one of the most hazardous. What makes these statistics tragic is that most of these fatalities could have been easily avoided. The first step towards protecting yourself in recognizing the many hazards you face on the job. To do this, you must know which situations can place you in danger. Knowing where to look helps you to recognize hazards. Inadequate wiring is dangerous, correct? So inadequate means proper sizing or rating. Exposed electrical parts are dangerous, right? So what is those? Those are open wires, weakened insulations, open to weather, open circuits or wires. Overhead power lines are dangerous, irrespective insulated or non-insulated. Wires with bad insulations can shock you. Electrical systems and tools that are not grounded or double insulated are dangerous. Overhead circuits are dangerous. Damaged power tools and equipments and are electrical hazards. Using wrong PPE is dangerous. Using wrong tools is dangerous. Some on-site chemicals are harmful. Defective ladders and scaffolding are dangerous. Ladders that conduct electricity are dangerous. Electrical hazards can be made worse if the worker location or equipment is wet. Some basic terms you must know and understand its importance are volt. What is volt? Ampere. What is ampere? Ohm. What is ohm? And series circuit. What is series circuit and parallel circuit? Correct. So let's start with volt. So what is volt? A volt basically is a measure of electrical force that seems to push the current along. Think of a voltage as a lot of water in a high water tank. So what will happen? Because water is high, the water will have more force behind it as it flows down the water pipe to your home. If the same tank was placed at ground level, your water pressure would not be as great. So the symbols commonly used for voltage are E or V. You can see them in your meters or displays. Now, what is ampere? An ampere is the unit used to measure the amount of electrical current. Amperage is often referred to as current by electrical workers and engineers. Let's go back to the water tank theory. So what is it? If the diameter of the pipe coming from the water tank is large, a lot of water or amperage will flow through the pipe. If the pipe diameter is small, a smaller amount of water will flow through the pipe. If you need a lot of current, many amperes, to operate the equipment, you will need larger wire to run the current, or they will burn up. The symbol of amperage is I. Now, what is ohms? Think of ohm as resistance. An ohm is the unit used to measure the opposition, that is resistance, to the flow of electrical current. Using our water analogy that we are talking about right now, a small pipe, water pipe, is going to oppose a lot of water from flowing. Relatively little water will be able to flow through the pipe. So the pipe offers a high resistance to the flow of water. You can see that large pipe would offer little resistance, so the flow of water will be better. Correct? So big pipe, a lot of water. It's that simple. The electrical circuit component are usually sources of resistance. Any component that heats up due to electrical current is a source of resistance. The symbol of resistance is R. What is series circuit? The current in a series circuit takes only one path. For example, water from high in a mountain may flow down the stream in a series way into a river that flows to ocean directly. So it is a single line, single pipe and single flow. Correct? Now, what is parallel connection? The current in the parallel circuit takes many paths. So there are many paths there. For example, the water flowing from a water tank up to hill, upon the hill, and flows in many different water pipes before it reaches the ocean. So here you must realize the difference in series and parallel circuits. If current is flowing in series, you utilize water from one single stream. It will reach less to the ocean, but the parallel for paths of same size for any individual source, same size stream, it will have more for each. So consumption is same, but source that each receives is same. Now, once we have understood the basic definition, now it will become clear to understand the severity of the electrical shock. So what is severity of electrical shock? Severity of injury from electrical shock depends upon the amount of electrical amperage, that is current, and the length of time the current passes through the body. For example, 1/10 of an ampere of electricity going through the body for 2 seconds is enough to cause death. The amount of internal current a person can withstand and still be able to control the muscle of the arm and hand can be less than 10 milliamperes. Milliamperes or MA, small m and A, that is the symbol of it. Now, currents above 10 milliampere can paralyze or freeze muscles. When freezing happens, a person is no longer be able to release a tool, wire, or other objects. In fact, in electrical field, the electric field objects may be held even more tightly, resulting in longer exposure to the shocking current. For this reason, hand tools that give a shock can be very dangerous. So your first focus is demanding in selecting proper insulated hand tools, not self-made but proper manufactured ones. If you can't let go of the tool, current continues through your body for a longer time, which can lead to respiratory paralysis. The muscles that control breathing cannot move, and you may stop breathing. People have stopped breathing when shocked with currents from voltage as low as 49 volts. Now, usually it takes around about 30 milliamperes of current to cause respiratory paralysis. Now, currents greater than 75 milliamperes may cause ventricular fibrillation, very rapid, ineffective heartbeat. This condition will cause death within a few minutes unless a special device called defibrillator is used to save the victim. Heart paralysis occurs at 4 ampere, which means the heart does not pump at all. Tissues is burned with current greater than 5 amperes. The muscle structure of person also make a difference. People with less muscle tissue are typically affected at lower current levels. Even low voltages can be extremely dangerous because the degree of injury depends not only on the amount of current but also the length of time the body is in contact with the circuit. Now understand this one. One must understand this simple table effect. Correct. So low voltage does not mean low hazard. So this table shows what usually happens for a range of current lasting 1 second. At typical household voltage, longer exposure time increases the danger of shock victims. For example, a current at 100 milliampere applied for 30 seconds is dangerous as current of 900 milliampere applied for a fraction of second, that is 0.03 seconds. Now the effect of current on body, it's very simple. What we are seeing in the table, 1 milliampere will just give you a faint tingle. 5 milliampere will give you a slight shock, disturbing but not painful. Most people can let go, however a strong involuntary movement can cause injury. Now 6 to 25 ampere in women and 9 to 30 milliampere in men will give you a painful shock. Muscular control is lost. This is the range where freezing current starts. So it may not be possible to let go. Now at 50 to 150 milliamperes, extremely painful shock will occur. Respiratory arrest, breathing stops, severe muscular contraction happens, and flexor muscles may cause, holding on the extensor muscles may cause intensive pushing away. So heart fibrillation possible, and death is also possible in this. 100 to 4,300 milliamperes, that is 1 ampere to 1000 amperes, 1000 milliamperes to 4,300 milliamperes will cause 1 to 4.3 amperes will cause rhythmic pumping action of the heart causes, and muscular contraction and nervous damage occurs likely, death will likely occur in this. At 10,000 milliamperes or 10 amperes, cardiac arrest and severe burns occur. Now death is probable. Now 15,000 milliamperes or 15 ampere, the lowest overcurrent at which a typical fuse or a circuit breaker opens a circuit. So at this, you can imagine at 10 amps only a person will be all dead with fraction like 1 second exposure. So effects are for voltage less than 600 volts. Higher voltages also cause severe burns, and differences in muscle and fat content affect the severity of the shock. Now the electrical burns part. So let's see what is there. So electrical burn, the most common shock related non-fatal injury is burn. So burn caused by electricity may be of 3 types: electrical burn, arc burn, or thermal contact burn. So electrical burns can result when a person touches electrical wire or equipment that is used or maintained improperly. They are one of the most serious injuries you can receive and usually requires immediate attention. Now arc burn. So arcing is luminous electrical discharge that occurs when high voltage exits across the gap between the conductor and the current travels through the air. Now the temperatures are as high as 35,000 degrees Fahrenheit. That is approximately 19,426 degrees Celsius. Now imagine that kind of temperature high. Now have been reached in arc blast. Now arc blast occur when powerful high amperage current or arc is distribution in a distribution box or a motor control center. That's a confined flash, or arc in an open space with an energy escaping in 360 degrees in all directions. That is called an open flash. Now what is thermal burn? So thermal burns occur when electricity starts a fire or explosion. Clothing may catch fire and thermal burns may result from heat of the fire. Extremely high energy arc can also damage equipment, causing fragmented metal to fly in all directions. Now, what is arc blast hazard? So, when arc blast hazard, there are three primary basics. So, there are three primary hazards associated with arc blast. Arcing due to arc blast gives off thermal radiation, that is heat, and intense light, which can cause burns. Several factors affect the degree of the injury, including skin color area and skin exposed, and the type of the clothing that you are wearing. Proper clothing, work distance, and overcurrent protection can reduce the risk of such burns. A high voltage arc can produce a considerable pressure wave blast. A person 2 feet away from a 25,000 ampere arc feels like a force of 480 pounds, that is approximately 200 kg plus on front of the body. So imagine you have been pushed by a 200 kg, sumo kind of man. So what will happen? In addition, such an explosion can cause series of ear damage, memory loss due to concussion. Sometimes the pressure wave throws the victim away from the arc blast. While this may reduce the further exposure to the thermal energy, serious physical injury may result. The pressure wave can propel large objects over greater distances. In some cases, the pressure wave has enough force to even snap the head of the steel bolt and knock over walls. Now, what are metal burns? A metal at a high temperature from 5,000 to 35 degrees Fahrenheit, high voltage arc can also cause many of the copper and aluminum components in the electrical equipment to melt. Now, these droplets of molten metal can be blasted at a greater distance by pressure wave. Although these droplets harden rapidly, they can still be hot enough to cause serious burn and cause ordinary clothing to catch fire, even if you are 10 feet from away from the blast. If the splinter will come to you, so you will definitely get burned. Now let's talk about what should be the system. Simple 3 steps and properly thought of electrical safety program to make sure all employees are safe before before, during, or after electrical work is performed. Electrical workers should follow 3-step process of electrical safety program. Now, what are these 3 steps? Simple: recognize the hazard, evaluate risk, and control the hazard. To be safe, you must think about your job and plan for hazard. To avoid injury or death, you must understand and recognize hazard. You need to evaluate the situation you are in and assess your risk. You need to control the hazards by creating safe work environment, by using safe work practices, and by reporting hazards to the supervisor, area in charge, or even the trainer who is giving you training on all safeguards available. If you do not recognize, evaluate, and control hazards, you may be injured or killed by the electricity itself. Now, electrical fire or falls, if you use electrical safety program to recognize, evaluate, and control, you will be much safer at workplace. Now, how to do it, right? So, the use of safety program. So, it is very simple. Safety model does what? Recognizes, evaluates the control hazard, identify the electrical hazard, don't listen to the reckless or dangerous people, evaluate your risk, take steps to control the hazard. Now, starting with the recognition of the hazard, the first step of electrical program is recognizing the electrical hazards around you. Only when you avoid or control the hazard, it is best to discuss the plan hazard recognition task with your co-workers. The most frequent cause of electrical injury or death are contact with power lines. See if it's possible and in which task. Lack of ground fault protection. Mostly people think that it's done 3-pin or by panel. That's not enough. Each equipment need it separately. Remember, source current is coming, but where it will drain unless provided a path in case of leakage. Now, path of ground missing or disconnected. If you have earth provision for each equipment and panel, then ensure that its continuity is checked and proper checks are done when you are testing earth bits. Each continuity for path or earth also is it should be connected. How to do it? Simple. Have provisions for checking continuity. Now, equipments not used in manner prescribed, often found that extension or modification bypass practices being up this challenge. If you want to try out something, always ensure it's restored to its original intended state also. Improper use or extension and flexible cords. Now, extension cord is temporary connection, cannot be fixed supply. Also, mostly this is not part of load calculation. So, cable rating and connected and functional load to be done. Now, coming to the evaluation of risk part. So, when we talk of evaluation is basically judgment call, and it's based on the perceived level of risk of injury. Now, risk is determined by analyzing the probability of an injury occurring and the severity of the injury if it occurs. The greater the probability and higher the severity, the greater the risk. When evaluating risk, it is best to identify all possible hazards first, then evaluate the risk of injury from each hazard. Do not assume the risk is low until you evaluate the hazard. It is dangerous to overlook the hazard. Now, the third point is control hazard. Once the electrical hazards have been recognized and evaluated, they must be controlled. You control electrical hazard in two main ways. First, create a safe work environment and use safe work practices. To post, we posted a video on JSA earlier. Here, let us, take this by an example to understand the control part. So let us have these three columns: task, hazard, and precaution. Now, the first task is removing the cover. So electrical shock and exposure to live wire. What are the precautions that you can take? You can de-energize by opening circuit breaker or removing fuse. Now, removing GFCI, possible, other live wires in opening, that is the hazard. And what are the precautions? Test wire with appropriate voltmeter to ensure all wires are de-energized. Installing GFCIs, ground fault circuit indicators. So what we have to do, what is the hazard? Possible connecting wire incorrect. So check wiring diagram to ensure proper connection before energizing. Replacing cover or re-energizing. So possible defective GFCIs. So test GFCI. So once the JSA or JHA is complete, use it to train employees who are not familiar with the job for retraining if employees demonstrate lack of knowledge, skill, or ability. Make sure the JSA is reviewed each time the employee must perform a hazardous procedure. Thank you, everyone. So hope we were able to give you much information on hazard control in electrical safety. For your support. Like I said, Safety Shorts is a series focusing on small safety videos. Thank you for all your support. Keep liking and sharing and subscribe for our motivation. We'll keep on posting more such videos. Till then, be connected and stay safe.